Welcome. Today, we're diving into pressure management across different cleanroom grades. A, B, C, and D will explore how maintaining the right pressure levels is crucial for contamination control and overall cleanroom performance. Let's get started with the fundamentals and why they matter in these controlled environments. Let's dive into cleanroom grades, a key part of maintaining sterile environments. Grade A is the heart of critical aseptic zones, where sterile products are directly exposed. Think aseptic filling, open vial filling, or sterile stopper loading. Surrounding that is Grade B, the background environment supporting Grade A. Then we have Grade C, used for preparation and less critical tasks. Finally, Grade D covers support and initial processing areas. The goal here is clear: to keep cleanliness progressively tighter, using controlled pressure cascades to protect every step. Pressure management is a key part of keeping sensitive environments safe and clean. When we control pressure differences, we create airflow that stops contaminants from sneaking into critical spaces. This protects products, ensures sterility, and prevents cross-contamination. It also helps maintain cleanroom standards and meets regulatory requirements. The basic idea is simple: air always flows from areas of higher pressure to lower pressure. For example, Grade B areas are kept at higher pressure than Grade C, safeguarding aseptic processing zones. When it comes to regulatory expectations, there are some key requirements we need to keep front and center. The EU GMP Annex 1 calls for appropriate pressure differentials and continuous monitoring of critical areas. It also demands thorough investigation of any excursions, and that all of this ties into a broader contamination control strategy. Meanwhile, WHO GMP and PIC-S GMP focus on verified pressure cascades, environmental monitoring, and HVAC qualification. Over in the US, the FDA's CGMP rules emphasize that environmental conditions must prevent contamination and product mix-ups. These standards set the foundation for quality and safety. Let's talk about airflow direction and how pressure differences help us keep things clean. The goal here is simple: air should always flow outward from the cleanest areas toward less clean spaces. We do this by creating a pressure cascade, where Grade A and B areas have the highest pressure, around 35 pascals, then Grade C drops to 25, Grade D to 15, and the corridor sits at about 5 pascals. This steady pressure difference, usually between 10 and 15 pascals between rooms, ensures contaminants don't drift back into cleaner zones. It's a subtle but crucial part of good industry practice. Let's talk about managing pressure in Grade A areas, the most critical zones in a cleanroom. These spaces demand the highest level of cleanliness and use unidirectional airflow to keep products safe. Because these areas are so sensitive, they're usually protected by the surrounding Grade B environment. Take an aseptic filling line, for example. The Grade A workstation has focused airflow, while the Grade B room around it helps maintain pressure. This pressure difference is key to stopping contamination from getting in. And to keep it all in check, continuous monitoring of both the environment and pressure is essential. Now let's look at pressure management in Grade B areas. These spaces act as a buffer, protecting the more critical Grade A zones. The typical pressure here is about 30 to 35 pascals higher than the adjacent Grade C areas. For example, if Grade B is at 35 pascals and Grade C at 22, the pressure difference is 13 pascals, a good, acceptable cascade. If this balance fails, airflow can reverse, raising contamination risks and potentially compromising sterility assurance. Managing this pressure is crucial for safety and quality. Let's talk about pressure management in Grade C manufacturing areas. These spaces handle tasks like solution and equipment preparation, plus component washing. The typical pressure here sits between plus 20 and plus 25 pascals. The goal is clear: keep the product safe from contamination and maintain a firm separation from lower grade areas. For example, if Grade C is at plus 25 pascals and Grade D at plus 15, that 10 pascal difference meets common industry standards. It's all about creating the right environment to protect quality. Let's talk about pressure management in Grade D support areas. These spaces handle tasks like initial material prep, washing, and other support activities. They're designed to act as a buffer, a transition between classified and unclassified zones. Typically, the pressure here is kept slightly positive, around 10 to 15 pascals. For example, if the grade D area is at plus 15 and the adjacent corridor is at plus 5, that 10 pascal difference ensures air flows toward the corridor, maintaining cleanliness and control. Now, let's look at pressure monitoring and alarm systems, a critical part of keeping environments safe and stable. We use a variety of instruments, from differential pressure transmitters and digital sensors to magnehelic gauges, to track pressure levels accurately. These feed into larger systems like building management systems, SCADA, or environmental monitoring systems. We set alarm limits, for example, a target of 15 pascals with alerts kicking in at 12 and action required at 10. When limits are crossed, automated responses trigger visual and audible alarms, plus SMS or email alerts, so no warning goes unnoticed. Let's look at a common example of pressure differences between two cleanroom grades. Grade B and grade C, the specified pressure difference should be 15 pascals, but what we observed was only 8. This gap can come from several causes. It might be HVAC problems, like a fan failure or a blocked HEPA filter. Operational factors, such as doors left open or too much movement, also play a role. Instrumentation issues like sensor drift can mislead us. In this case, the investigation found a partially blocked HEPA filter. The corrective action was to replace the filter and rebalance the airflow. When pressure management works well, the benefits ripple across the entire operation. Product quality gets a boost, contamination risks drop, and sterility assurance improves. Operational efficiency follows, with stable environments and fewer unexpected deviations. Compliance becomes easier, too, inspections go smoothly, and strong GMP standards are met consistently. Achieving this means following best practices, like qualified HVAC systems, scientifically designed pressure cascades, continuous monitoring, and rigorous data integrity. Together, these steps keep everything running safely and smoothly. Pressure management in cleanrooms, from grade A to D, is absolutely critical. It keeps contamination out, protects products, and helps meet strict regulations. The key is a well-designed pressure cascade, where air flows from the cleanest areas to the less clean ones, reducing cross-contamination risks. Consistent monitoring and maintenance, backed by a strong contamination control strategy, ensure these pressure differentials hold steady. When we combine smart engineering, risk-based checks, and good manufacturing practices, we create cleanrooms that perform reliably, stay inspection-ready, and support the safe, high-quality medicines we all depend on. Thanks for joining me today. If you'd like to explore this topic further or have any questions, please don't hesitate to reach out. I appreciate your time and attention, and I look forward to continuing the conversation. Thank you. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.